so let's just have a look at some of these. If you don't have your textbook, it's no big deal because what I did was I copied out the question for you. I realized a few years back that when kids are done grade 12 physics, they're going to turn in their textbook. There may be some that decide to take physics at university, and if you are planning to do that, I strongly suggest you hang on to your notes. And then these samples are a lot more useful to you because of the question. So that's why I typed them in there. All right, so I would suggest that you hang on to those for future reference. Example number 7 is pretty straightforward here. Kitty O'Neill, a female dragster, reached a speed of 628 kilometers an hour from rest in 3.72 seconds. How far did she travel in that time? So let's just figure this out. Let's see if I can do it without my notes. We're given two speeds here. This is the final velocity. Brennan, are you watching now? Time to begin, man. Put the device away. This is the initial velocity. And we are asked for, this is the time, and we are asked how far, so that's our d. So which one has d, vi, t, and vf all in it? Which one of the three special ones? Vf equals vi plus at, no d in there. D equals vit plus a half at squared. We don't have acceleration. Vf squared equals vi squared plus 2ad, I don't have acceleration. So it looks like I'm going to have to do two steps here, right? So what would you suggest we do? Jake, I need you to put it away now. Oh, you're calculating. Awesome. Okay. So what do I need to do? Step 1, as soon as you saw kilometers per hour, I'm hoping you realized that you should probably convert that. Okay? So let's do that first. So it's 628 divided by 3.6, and I'm going to have to get a calculator. Really? Well, I guess it is though. $174.4, right? 174 meters per second. That's like 1.5 football fields in a second. It's fast. She's doing 628 kilometers an hour. Okay, so that is our time. Divide by 3.6, right? Do you think we need to find the acceleration?
Would be helpful.
Yes, because both of them, this has a in it, that has a in it, that has a in it. I can't do any of them without the acceleration, right? So I'm going to use Vf equals Vi plus At to find the acceleration. The final velocity is this 174.4. The initial velocity is our 0. All right, acceleration is this number. No, that's what we're solving for, right? And our time is 3.72, right? So our acceleration is 174.4 divided by 3.72. 46.9.
You just added in a few steps that really didn't.
Did I? What did I do? What?
Well, you use one of the derived formulas to
Yeah.
get pretty much exactly A equals delta V over T.
It is basically the same, yes. Delta V is just what?
Yeah.
Yeah. I didn't really, it's just using a different version of the formula. I didn't really add a step. Because you would still need this one, right?
Well, but you did because you had to rewrite it.
I guess.
You had to-
Fair enough. Fair enough. Okay, so that's our acceleration. Now to find the distance, which one would you use? This one? This one or this one? Probably easier to use this one because it's written as d equals, so let's use that. Initial velocity is 0, that's always nice. Acceleration of 174.4, time 3.72 squared. Make sure you square it. Oh, I screwed up. I put velocity in for acceleration. So take 46.9 times a half multiply by 3.72 and square it. I get 324.5 meters. Anyone else get that? Or pretty close? Did I forget something? 3.72 squared?
Yeah, there's initial velocity.
Oh, okay. Do I need it in there? If the initial velocity is 0, what I normally do is I just put 0 there, right? Because I guess what I'm saying is that these two combine to give you that, right? Okay? I guess just because I've done it so many times. But good point. I got the same. Okay, so that's like a 2-step counter. I guess 3 steps, really. All good? Yeah? Okay, let's look at the Ferrari one here. Moving at 20 kilometers an hour, accelerates to 230. As it does so, it covers an unknown distance. Again, find the distance. Is this not exactly the same question? Exact same question. There's only one small difference, besides the fact that it's a Ferrari and we have an initial velocity, don't we, right? So you guys can probably follow the steps and do it. I'm just going to do it up here, but you're more than welcome to... should I convert those to meters per second and then subtract, or should I subtract and then convert to meters per second? Doesn't matter, although one way is one less thing to do, right? If you subtract first, 230 minus 20 is 210 divided by 3.6. $58.3, and that's my change in velocity. Why it wants me to use this one, delta V over delta T. 58.3, my time is 7.5. 7.78 meters per second squared is the acceleration. And there are various ways that you could solve this.
Initial velocity isn't 0 here.
I'd like to say I made that mistake on purpose, but I didn't. Good catch. Oh, so what do I have to do? I'm going to have to take that 20, right? Yeah, I'm going to have to. Because it's got to be a meter per second. The VF too?
Yeah.
Why? Not here, there isn't. Yeah, if I'm using this one, I'm okay. Good catch. So 5.56, the time is 7.5, 1/2 the acceleration of 7.78 times 5.56 squared. Lots of math in there. I get 260.8. Although I have to admit I did it a slightly different way, so if I did the actual math, it might be rounded slightly different, but about 260.8.
You put the time in wrong.
Did I?
There.
What did I
The
do?
initial velocity
Oh. Oh, I did, didn't I? Right here. Time should be 7.5. What did I have in there? Did I? I might as well just quit and go home. Take the day off. I'm losing it. Okay, let's look at number 10. Calculate calculate the acceleration of an airbag if it deploys in 30 milliseconds and moves it to 40 centimeters. Now, what are your spider senses telling you is going on here? Milliseconds, centimeters, right? You're going to have to convert. Milli means thousandth, right? So 30 milliseconds is 30,000th of a second. So we're going to divide by 1,000. We're going to move the decimal place 3 places left. We're going to get 0.03. And our distance is 40 centimeters divided by 100. Centi means 100, so 0.4 meters. We are looking for acceleration. We've got time, we've got distance. Do we have anything else? I don't have any velocities here.
You know the initial velocity.
What is the initial velocity? 0? Does it matter if the car is moving?
No, because of our record, it's a car.
Is she right? Yes. Regardless of if the car is at rest. Have you ever seen that video where the granny's crossing the street, the guy honks the horn, and the granny takes her purse and slams it on the car door, and what happens? Or on the hood of the car, and the airbag explodes? You ever seen that? You guys are missing out. I just described it. Yeah. Yeah. I'll see if I can find it. Because the guy laid on the horn while she was crossing slow. She was kind of, shuffling across the street like this while the guy was he honks the horn and tells his granny, get moving, right? And she takes the purse and slams it on the hood. Airbag explodes. Sort of different. So yes, does it accelerate any faster or slower if it's moving or stopped? No, it doesn't. So Monique is correct. The reference point is inside the car, it's 0. So yes, initial velocity is 0. Good.
It would serve him even better if he was taking the start button.
Yes. Okay, so I'm going to write D equals
Especially if it was very fresh and very hot.
very hot, yes. And he was horribly disfigured for the rest of his life.
And if he had it in a reusable mug, so it also.
Steel one. Yeah, broke his nose too, right?
Yeah.
Yeah.
His nose is beautiful.
Okay, so the distance traveled is 0.4. The initial velocity is 0, right? So that's good. 1/2 our acceleration, which is what we're looking for. And the time is 0.03 squared. Okay, so I got 0.4 is equal to that. 0 disappears. I got 1/2 of 0.03 squared. 0.03 squared is 0.009, 0009, and I need half of that. So that's going to be 0.00045A, giving me an acceleration of 0.4 divided by 0.00045. Really big or really small number? You're dividing by a really small number, so it's going to be really, really, really big, right? And the acceleration of an airbag has to be really big so that it can get to you in time. I get 888.9 meters per second squared. That thing is moving fast when it hits you. Okay, last one's a little bit harder, then I'm going to give you some time to practice here. Jane Bond, that's James's cousin, runs down the sidewalk, accelerating uniformly at a rate of 0.2 meters per second squared from her initial velocity of 3 meters per second. How long will it take Jane to travel a distance of 12 meters? Acceleration, 0.2. Initial velocity of 3. We're looking for time. distance is 12. We're looking for t, given d, vi, and a. Hey, this is just d equals vit plus 1/2 at squared, right? What's the d? Displacement, 12. Initial velocity is 3. Uh-oh. Do you know what's happening here? What do you do when you got t squared and t? Quadratic equation. I'll wait for the cheering to die down. When you got t and t squared, you move everything to one side and you put 0 on the other, right? So 0 equals, do you like having the t squared in front?
Yeah.
Most people do. So 1/2 of 0.2 is 0.1 t squared plus 3t minus 12 is equal to 0. Okay, I moved everything to one side. Did I lose anybody yet? No, I'm good. And what do? You gotta use the quadratic formula. Anybody want to try factoring that? Be my guest. You won't get it. Not in a million years will you get it. It is factorable, but you won't get it. Okay, so quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And I think I will remember that till my last day. I won't think about it, but if you ask me on my last day, I will know that. I've used it that often. That's kind of a depressing thing for me. Lying in a hospital on my deathbed, someone asks me the quadratic equation formula, and I'll know it. Might not know my own name. Okay, so the A, B, and C, the A is 0.1, the B is 3, right? So this is going to be minus 3 plus or minus square root. B squared is going to be 3 squared minus 4. The A value is 0.1. And the C value is minus 12. And it's all over 2 times A, which is 0.1. Hey, you remember those good old days when we didn't show our work? We just sort of did it, just sort of punched it in the calculator? Those days have long gone, yes. Thank you, Wyatt, for finally coming over to the dark side.
I still don't accept it.
Mm.
I'm still not fully there.
Plus or minus, so I'm going to take this whole thing here. I'm going to go 3 squared, which is 9, minus 4 times 0.1 times negative 12, and I get 4.2. Hang on here. 3 squared. That's 4 times 1 times 13.8. And then square root. 3.7. Plus or minus 3.7. Is that what you got? All over 0.2. Now, when you do quadratic formula, really what you're doing is you're solving for, and I don't even know which way this goes, you're solving a parabola, you're solving for the zeros, right? That's what you're doing when you're doing the quadratic formula, right? So you have to do minus 3 plus 3.7 divided by 2 and minus 3 minus 3.7. And you're going to get 2 values. You're going to get 3.5 seconds or you're going to get minus 33.5 seconds. Can you have 2 answers? Well, I got minus 3, subtract 3.7 gives you minus 6.7, and then divide by the 0.2. Can you have 2 possible answers? Well, in math you can, but in physics, generally you don't. And I'm not going to say never, right? Is the 3.5 the right one? Yeah, it is. What is the meaning of the minus 33.5 here? Well, she is accelerating uniformly at 0.2, right? Well, if you continue forward in time, she will go faster and faster and faster, and eventually will travel 12 meters, right? If you go back in time, her distance traveled will be 12 meters as well, but sort of in that she would have to be accelerating uniformly at point 2 in the opposite direction type of thing. Like, it doesn't make a lot of sort of sense. And so really, generally, when you're solving for time, you only need to solve for the one that's positive. This one doesn't exist, the answer. Okay? You probably haven't seen one quite like that yet. Fun times. Okay, I will stop. You can start. Is there questions in the book? No, they're not, eh? Who do I have on mine here? We'll get to Fred and Barney tomorrow. If you want questions in the book, I'll have to find them here. They are on page. Okay, if you want textbook questions to work on, page 64, 1 to 3. Page 73, numbers 33 to 66, leaving out 50, 54, 55, and 60. There are some in there where there's 2 objects, like people catching buses and things crashing into each other. Leave those until I do the questions tomorrow. I'm sure you won't get that far. You can work on those ones as well. Okay? So I'll give you some time to work. You've got about a half an hour, almost 45 minutes. Do a few problems. Get better at it. Sure. You guys know that physics is just like sports or music or what have you. You got to train, you got to practice. So it just takes time.